I have a problem on electrostatics. Let's first go through the problem thoroughly. A thin half ring of radius r is equal to 20 centimeter uniformly charged with a total charge q is equal to 0.70 nanocoulomb. Find the magnitude of the electric field strength at the curvature center of this half ring. Let's draw the problem. This is my half ring. Q amount of charge is uniformly distributed over here. Radius of the ring is capital R. I have to find electric field at O. For this kind of problem, what I have to do, I have to take a small length dl tends to 0 on the ring. And now I will calculate electric field at O due to the little amount of charge which is distributed over this dl. So let's first calculate how much amount of charge is distributed over dl. Before that, let d theta is the small angle subtending by two extreme points of dl with O. This length is capital R also. As d theta and dl both are small, so I can write dl is equal to r d theta. Now charge at dl be dq, and this dq will be equal to q by pi r, where pi r is the length of this half circle multiplied by dl. Q by pi r is the charge per unit length. Putting the value of dl, I get dq is equal to q d theta by pi. Now due to this little amount of charge, I will calculate electric field at O. Let this electric field be dE, and that dE will be equal to 1 by 4 pi epsilon naught dq by r square, that means q d theta pi into r square. Now if I perform integration over whole the wire, then I will get total value of electric field at O. But before doing this, let's see the direction of electric field at O due to this little charge. As this charge is positive, so electric field will direct in this direction, radially outward. Let us consider this angle with theta. So this angle is also theta. So I will get two components of this electric field dE. One is dE cos theta, which can be treated as horizontal component, and another is dE sin theta, which can be treated as vertical component. Now if you see the symmetry of the problem, when we are going to perform the integration, then for this half of the circle, I will get horizontal component of electric field in right direction from O, that is right from O. And for the rest half of the circle, I will get the horizontal component direction leftward from O, because if you consider dl in this region, then E will be directed in this direction, and it has horizontal component is this direction and vertical component in this direction. So if you take the whole wire, then the horizontal component will be cancelled out, but the vertical component will always direct downward. So vertical components will add up to give you the total value of electric field. So when you are going to calculate a total electric field at O, you have to perform integration over dE sin theta, and that will give me the total value of electric field at O. And I have to perform the integration on the limit 0 to pi, because the given ring is a half ring. Now let put the value of dE, which is equal to 1 by 4 pi epsilon naught q d theta by pi r square sin theta 0 to pi. Now let's bring the constant part outside the integration, that is q by 4 pi square epsilon naught r square, and in between the integration sign I have to write sin theta d theta, and I have to perform the integration over 0 to pi. Let's perform the integration. This is my constant part, and integration of sin theta will give me minus cos theta, and let's put the limit pi and 0. So q by 4 pi square epsilon naught r square minus cos pi plus cos 0. Now as cos pi is equal to minus 1, so minus cos pi equal to plus 1, and cos 0 equal to also plus 1. So I will get 2 on the numerator. So after calculating, I will get q by 2 pi square epsilon naught r square. We just cancel these 2 with this 4 and get 2 on the denominator. So this is my value of integration, and this is the value of electric field at O. Now if I put the value of q and r, that is q is equal to 0.70 nanocoulomb, which is equal to 0.70 into 10 to the power minus 9 coulomb, and r is equal to 20 centimeter, that is 0.2 meter, and put the values on E, I will get E is equal to 100 volt per meter. This is it. Thanks for watching.